Welcome. Today we are going to discuss learning theories and how you can apply these theories in your classroom. We will discuss the cognitive load theory, the cognitive theory of multimedia learning, and refutation texts. There will also be a short teaching demonstration which illustrates these theories in refutation texts. Let's begin. Let's start with the cognitive load theory. When we learn about cognitive load, we must understand the concept of short-term and long-term memory. Short-term memory is very limited and can only process 2 to 4 pieces of novel information at a time. We must keep this information at the forefront of our minds. While the short-term memory is very limited, the long-term memory is virtually limitless. Our goal is to design instruction that moves new information from working memory into the long-term memory. We can only move large amounts of information if they have been broken down and organized. When a person learns new information, there are 3 types of cognitive load. Intrinsic cognitive load. This is the innate load caused by the interacting elements of the material that's being processed or learned. Extraneous cognitive load. This load is caused by unnecessary elements that are put into place by the teacher or the instructional designer. Our goal is to keep that to a bare minimum. And germane cognitive load. This refers to the working memory primarily working with intrinsic rather than extraneous cognitive load. It can be thought of as the goal learning mode, when our learners are not distracted by outside factors and really focusing on the material. Let's move on to the cognitive theory of multimedia learning. This theory is built upon the assertion that humans gain deeper knowledge when they learn with images and words rather than words alone. These images can be digital or print, static or dynamic, and the words can be written or spoken. The key is that multimedia instructional methods are employed with a sensitivity to understanding how human brains process new information. Let's begin by discussing the 3 assumptions of the cognitive theory of multimedia learning. Think of these assumptions as the ground rules for understanding this theory. First is the dual channel assumption. It's that humans process information into 2 separate channels, verbal and visual. This concept potentially doubles the amount of information that the working memory can process at one time. Next comes the limited capacity assumption. This assumption states that limited capacity within each channel to process information in the working memory at any one given time. And lastly, the active processing assumption. Humans actively engage in paying attention to new information, organizing it into a cognitive structure, and integrating it with prior knowledge. In other words, learning cannot be a passive activity. It takes the work of both short and long-term memory to make learning meaningful. When a person is learning something new, the multimedia learning theory identifies 3 processing demands on cognitive capacity. 1. Extraneous. This comes from unrelated information, usually poorly designed lessons. 2. Essential. This is selecting vital information and memorizing it. And 3 is generative, aimed at creating organization and meaning within the material. Next, we'll discuss the 3 learning principles and see them demonstrated in a teaching segment. First, let's talk about the redundancy principle. The redundancy principle states that information that is not necessary to the learning goals should be removed. This principle has 2 variations. One is identical information that is being presented simultaneously in different ways. For example, words being on a slide at the same time as a narrator reading the words aloud. The second variation is when we attempt to elaborate on a concept and end up being redundant. For example, in studies, students perform better on summarized text than on the original, lengthier text. Instructional designers should spend time considering what is essential information in reference to their specific learner. What is redundant for one learner may be essential for another. Eliminating redundancy from instruction works because it reduces extraneous load. Next, we'll talk about signaling. This is the principle that refers to the findings that people learn more deeply from multimedia presentations when cues are added to highlight important ideas and organize information. Signaling has been studied in the cognitive theory of multimedia learning with 4 variations of cues. Text-based cues like changing a font color or adding a highlight. Auditory textual cues like emphasizing words with inflection or pauses. Picture-based cues. They can be used when blurring part of an area to bring another area forward, or cueing corresponding elements in text and pictures. For example, if all words and pictures associated with a certain biological process were labeled with the same color. This helps learners to integrate and organize information. This has a positive effect because it reduces the student's cognitive load. The coherence principle, proven in multimedia learning, suggests that spicing up lessons with related but unessential information actually hinders learning. This principle stands in contrast to many of our personal experiences in education. We all had teachers who were great storytellers and loved to go off on a tangent, but those experiences might be fun for the learner. They do not aid in reaching our learning goals. Instructional designers who seek to distill learning and essential information are catering to the limited capacity of the working memory. In reducing cognitive load, concise lessons prove time and again to receive better transfer test scores. Finally, we'll discuss the benefits of refutation texts and the conceptual change theory. From the lens of the conceptual change theory, refutation texts increase the chance of conceptual change occurring. Conceptual change takes place when a learner replaces or revises a knowledge structure. Refutation texts utilize three elements: 1, a common misconception in the subject area; 2, a refuting cue; and 3, a sound explanation that is backed by science or significant evidence about what the misconception has wrong. Studies have found that incorporating refutation texts in curriculum increases the likelihood of conceptual change to occur. Now let's watch a teaching segment in which I will demonstrate the redundancy, the signaling, and the coherence principle, as well as the refutation text in my classroom. Today we are going to learn about drawing with the grid. Many students resist this technique because it requires a bit of time to set up and understand. They argue that they draw better without it and that it's a distraction from their drawing process. However, ask any artist or art teacher from around the world and they will tell you that this process or a variation of it is the most helpful tools in teaching students how to draw. The use of a geometric shape helps students break the drawing into bite-sized pieces and see relationships within it. It allows students to draw more proportionally and more quickly. Learners become more advanced and begin to simplify this technique into a 4-quadrant grid in time. So let's begin. We begin by selecting our reference image for our drawing and printing it large on a piece of paper. Next, using a pencil and ruler, working from the top left-hand corner of the image, measure 1-inch hash marks across the top of your page. Slide your ruler to the bottom of the page and create your hash marks again. Using the ruler, connect the hash marks and create the vertical lines across your image. Beginning at the top left-hand side of the image again, create your hash marks down the left-hand side of the page. Slide the ruler to the top right side of the image and create those 1-inch hash marks again. Use your ruler and connect the horizontal hash marks across the image. Once you have drawn your grid, number the boxes across and down the page, starting on the top left-hand corner. Write down how many boxes you have across and down. Once you have a measurement, we want to enlarge it for this example by 150%. In order to do that, multiply each side by 1.5. With the result of that calculation, we now know that our new paper needs to be 10.5 by 9. At this point, bring me your measurement so I can cut you a piece of paper for this project that is proportionally equal to your computer image size. Now that we have our measurement and paper, you can create your new grid according to the proportional enlargement. In this case, you measured by 1.5 times. That means that instead of 1-inch grid, you will now have a 1.5-inch grid hash mark. Now that we have two proportionally equal pieces of paper, we can begin to draw our face utilizing the grid. The purpose of the grid is to break it down. We're going to look at our drawing one square at a time. Now we are going to zoom in on a singular box on the grid. First, we make small points on the drawing paper where the drawing interacts with the box. Try to ignore the fact that you're drawing a face or an eye and just look at where the points fall within the box. Once they are correct, you can connect them and begin to draw your piece. Once the outline of your drawing is completed, square by square, it's time to erase the grid from the background. Make sure you do not add any pencil shading, paint, or detail elements until after we erase the grid. Now that you have your drawing outline, you can begin to add artistic elaborations. You can add drawing elements to the composition, or you can just begin adding details with your pencil or your paint. In conclusion, I hope that your confidence when creating excellent instructional design has been improved by gaining a deeper understanding of these learning theories. It is essential that we continue learning and growing to best serve our learners. Thank you.